Let's start Unit 9 out with some nth roots. So you may be familiar with square roots, and that is an nth root with the number 2. So we're going to use different numbers and find different roots of things. So just as x squared and the square root of x are inverse operations, x to the n and the nth root of x are also inverses. Just to help you wrap your mind around that, here are some examples. So for example, 3 squared equals 9, right? So the square root of 9 is 3. Now we can go a little further. The 4 to the third power is 64. 4 times 4 times 4. And so the third root of 64 is 4, because 3 4s multiply to 64. 2 to the fifth is 32. And so the fifth root of 32 is 2, because 5 2s multiplied together make 32. So we can use nth roots to kind of undo any exponent. So a to the n equals b. The inverse of that is the nth root of b would equal a. Now when there's no index given, it's assumed to be a 2. So if there's no number, it's assumed that it's just a regular square root. Speaking of the index, that is the little number next to the root that tells you which root you're doing. And we have the radical symbol here, also called the square root symbol. And everything inside is known as the radicand. Just some vocabulary for you. So let's practice some of these. And really, we're just going to be using a calculator to find these roots. So let's get a calculator up here. And so we could calculate these without it by doing the prime factorization and then finding those prime factors, but this is much faster. So the way we do this, if I want to find the fifth root of 243 on this calculator anyway, I'm going to say 243. I have to go into my second menu here. This y root of x button is what I want. I click that and then hit 5. So the fifth root of 243 is 3. And we can check that by doing 3 to the fifth, just to make sure it does equal 243, and it does. So the seventh root of 128 is going to be 2, because 2 to the seventh is 128. The third root of 125, I'm guessing this is going to be 5. 5 times 5 times 5, I do believe, is 125. Well, it'll help if I put the right number in. The cubed root of 125, not the fifth root, is 5. And finally, the fourth root of 50. Let's see what we get here. We get a decimal, 2.659, etc. And it says round to 2 decimal places if necessary. This one would have been not really possible to find with prime factorization. So 2.66 there. 2.66 approximately to the fourth power would equal 50. Okay, now if the radicand, that's the inside stuff, contains powers with exponents, we just divide the exponent by the index. And if it doesn't divide evenly, you'll have some leftovers that'll stay inside the radical. But I believe for today, these notes, we don't have anything like that. So we'll simplify these roots. First, we'll find the fourth root of 16. So the fourth root of 16 there. Is 2, because 2 times 2 times 2 times 2 is 16. Now we just divide these exponents by 4. 4 divided by 4 is 1, so we have an x. And then for y, 8 divided by 4 is 2, so 2xy squared. Next one here, example B, we have the cubed root of 27. Well, that's 3. 3 times 3 times 3 is 27. For 12, x to the 12th, divide that by 3, we get x to the 4th. And 21 divided by 3 is 7 for y. For example C, we have a regular square root. There's no number here. So this is assumed to be a 2, regular square root. The square root of 81 is 9. 9 times 9 is 81. And then divide the exponents all by 2. So 9x cubed y. Let's do a few more here. Example D, we have the 5th root of x to the 30th, y to the 15th. So just divide these exponents by 5. X to the 6th, y to the 3rd. Now for a problem like example E here, we have this thing in parentheses, 2x plus 7, all to the 12th power. What we're going to do is kind of ignore this inside stuff and focus on this exponent. Treat this entire parentheses like one variable, like an x or a y or something. So what this really is going to equal is 2x plus 7. 12 divided by 4 is 3, so all to the 3rd power. Which we could then multiply out, but we are not going to do that. That's how that would work. So if you have something in parentheses like this, consider it one big thing. Just focus on the exponent. And then you'll be able to simplify that much quicker. Last one here, all to the 10th root of x minus 3, all to the 20th. So 20 divided by 10 is 2. This is x minus 3 squared, which would be an easier one to multiply out if we were doing that. But again, just like the previous example, we'll leave that like that because we are focused on roots today. So that's pretty much it. Use a calculator to calculate nth roots. Some of the smaller numbers you'll be able to do in your head potentially, but the larger ones would take way too much time. So calculator is the best way for it. And then if you have exponents on variables inside an nth root, just divide the exponent by the index.